Dear students, today we are going to discuss inverse trigonometric functions for plus 2 students. Before going to the chapter, we must take a review on relations and functions. You know what is function? A relation from a to b become a function if every elements of A have one and only one image in B. Such relations are called functions. A function from A to B can be denoted as f from A to B. In this function, A is called domain and B is called codomain. If the function f is defined from set A to set B, then every x element in A have an image in B. This function can be written as f of x equal to y. That means y is image of x. Then x is called pre-image of y. X is called pre-image of y. Next, types of functions. First one functions or injective function. A function f from A to B is called one function if different x have disjoint image. That is, f of x1 equal to f of x2 implies x1 equal to x2. Different x have disjoint image. Such functions are called one function. That is, two sets A and B. Every elements of A have unique image in B and images are different. Such functions are one functions. But in the second case, x1 and x2 have same image y1. That is, different x have same image. Therefore, it is not one or it is called many functions. Next, on to functions or surjective functions. A function f from A to B is said to be surjective if every elements in the codomain B have at least one pre-image in A. That is, range equal to codomain. If range and codomains are equal, such functions are called onto functions. That is, A and B are two sets. A function f from A to B defined like this. Now, all the elements in set B, that is codomain, have at least one pre-image. No elements are free in codomain, so such functions are called onto function. Next, we consider a function f from A to B. Here, the image of x1 is y1, image of x2 is y1, x3 is y3, x4 is y4. But the element y2 in codomain have no pre-image. Therefore, range not equal to codomain. So the function is not onto. Such functions are called into functions. Next, bijective function. A function is said to be bijective if it is both one and onto. Function is both injective and surjective. Such functions are called bijective functions. Invertible functions. A function is said to be invertible if its inverse exists. Function is invertible only if it is bijective. Inverse of f is denoted as f inverse. If f is a function from a to b, then f inverse is from b to a. Inverse of sin x can be written as sin inverse x. This read as sin inverse x. Sin inverse x not equal to sin x all raised to minus 1 or sin inverse x not equal to 1 by sin x. We know that sin x is defined from R to closed interval minus 1, 1. That is, domain of sin x is set of real numbers and the range is closed interval negative 1, 1. Then the graph of sin x is, from the graph of sin x, it is clear that in the entire domain R, sin x is not bijective. For example, sin 0 equal to 0, sin pi equal to 0, sin 2 pi equal to 0. That is, different x have same image. Therefore, sin x is not 1, 1. Hence, it is not bijective. Not bijective means sin x is not invertible in capital R. To make invertible, we have to reduce or divide the entire domain R into small groups. That is, if we divide the entire domain capital R into small groups or intervals like closed interval minus 3 pi by 2 minus pi by 2, minus pi by 2 pi by 2, pi by 2 3 pi by 2, etc. Sin x is 1, 1 and on to in these intervals. That is, sin x is bijective. If a function is bijective, then its inverse exists. Therefore, sin x is invertible in these intervals with range closed interval minus 1, 1. Therefore, these intervals are called branches of sin inverse x. Among these, the closed interval minus pi by 2 is called principal value branch or range of sin inverse x. That is, sin x is invertible in the interval minus pi by 2 with range closed interval minus 1, 1. That is, sin x from closed interval minus pi by 2 to closed interval minus 1, 1 is invertible. Therefore, the inverse of sin x exists in this interval. That is, sin inverse x can be defined as sin inverse x from closed interval minus 1 1 to closed interval minus pi by 2 pi by 2. That is, domain of sin inverse x closed interval minus 1 1 and range of sin inverse x is closed interval minus pi by 2 pi by 2. Domain and range of inverse trigonometric functions. Function sin inverse, domain closed interval minus 1 1, range closed interval minus pi by 2 pi by 2. Cos inverse, domain closed interval minus 1 1, range closed interval 0 pi. Cosec inverse, domain r minus open interval minus 1 1, range closed interval minus pi by 2 pi by 2 minus set 0. Sec inverse, domain r minus open interval minus 1 1 and range closed interval 0 pi minus set pi by 2. Tan inverse, domain r, range open interval minus pi by 2 pi by 2. Cot inverse, domain r, range open interval 0 pi. The value or principal value of inverse trigonometric functions means the value in its range. To find its principal value, we need this table or this values. It is already studied in first year. If y equal to sin x, then sin inverse y equal to x, and if y equal to sin inverse x, then sin y equal to x. In this chapter, it is very important one. If y equal to sin inverse x, then sin y equal to x. We discuss some questions. First one, find the principal value of sin inverse 1 by 2. Let y equal to sin inverse 1 by 2. Therefore, sin y equal to 1 by 2. From the table, it is clear that sin 30 equal to 1 by 2. So 1 by 2 can be written as sin 30. Instead, for 1 by 2, we express it as sin 30 degree. Now y equal to 30 degree. This 30 degree is clearly belongs to closed interval minus pi by 2 pi by 2. That is the principal value. Hence the result. Therefore, principal value of sin inverse 1 by 2 is 30 degree or pi by 6. Next question. Find the principal value of cos inverse 1 by 2. How to find the value? We can check it. For this, let y equal to cos inverse 1 by 2. Using the formula cos y equal to 1 by 2. From table, cos 60 is 1 by 2. So 1 by 2 can be written as cos 60 or pi by 3. Therefore, y equal to 60 degree, which is belongs to the range 0 pi. Therefore, principal value of cos inverse 1 by 2 is 60 degree. Find the value of tan inverse root 3. Let y equal to tan inverse root 3. Using formula tan y equal to root 3. From table we know that tan 60 equal to root 3. So root 3 can be written as tan 60 or tan pi by 3. Therefore y equal to pi by 3. This pi by 3 clearly belongs to the range of tan x, that is open interval minus pi by 2 pi by 2. Therefore principal value of tan inverse root 3 is pi by 3. Find the value of sec inverse root 2. Let's see the answer. Let y equal to sec inverse root 2. Therefore we can write sec y equal to root 2. Take reciprocal on both sides. Sec y become 1 by sec y, that is cos y equal to root 2 become 1 by root 2. We know that cos 45 degree is 1 by root 2. So instead for 1 by root 2, we can write it as cos pi by 4. Now cos y equal to cos pi by 4. Therefore y equal to pi by 4, which is clearly belongs to the range of sec inverse x, that is closed interval 0 pi minus set pi by 2. Find the value of cosec inverse 2. Answer. Let y equal to cosec inverse 2. Therefore cosec y equal to 2. Take reciprocal on both sides. Then cosec y become 1 by cosec y, that is sin y. 2 become 1 by 2. We know that sin 30 or sin pi by 6 is 1 by 2. So instead for 1 by 2, we can write it as sin pi by 6. Now sin y equal to sin pi by 6. Therefore y equal to pi by 6. This clearly belongs to the range of cosec inverse x. What is range of cosec inverse x? Minus pi by 2 pi by 2 minus set 0. That's the answer.